Today's topic is centripetal and tangential acceleration. Hello students, I am DATTA sir. I am a senior IIT JEE faculty for many years. In my long experience, I have seen the students struggle in some specific areas, and I have chosen those areas and making videos for them so that the students get benefited out of it. So if you are one of them, if you are benefited by this video, please like this video and share this video as much as you can. Also, since I will be posting this type of videos on a regular basis, please subscribe to this channel and press the bell icon so that you can get a notification whenever a new video is posted. Not only that, I want you to give your comments so that I can know what other concepts you want, so that I can make videos on that. So please note this. Okay then, let me start the topic. So the topic is centripetal and tangential acceleration. You know, in a circular motion, we know always there is an acceleration towards the center, which is called centripetal acceleration, and it is at 90 degree to the velocity. Velocity is tangential and this acceleration is radial. Now before going further, we have to understand something. See, what is the function of acceleration? Acceleration changes the velocity. If this acceleration is in the direction of velocity, then the speed increases. If it is opposite to velocity, then the speed decreases. But if it is perpendicular to velocity, then speed neither increases nor decreases. Then what is the function of this acceleration? The function of this acceleration then becomes changing the direction of velocity. If this acceleration continues to be at 90 degree with the velocity always, then the speed will not increase and the motion will be in a circle, which is called uniform circular motion. So whenever there is a uniform circular motion, the speed is constant and there is one acceleration which is towards the center. Now velocity is a vector, acceleration is also a vector. Now acceleration affects the velocity. Velocity has two elements, one is magnitude, one is its direction. So if the velocity is resolved in the direction of, if the acceleration is resolved in the direction of velocity and perpendicular to it, then we get two components. The component which is in the line of velocity, it changes the speed. So either it increases or decreases the speed. And the component which is perpendicular to velocity, it changes direction. It is happening in uniform circular motion. So in uniform circular motion, there is one acceleration which is radially towards the center. Now, we know that the uniform circular motion, there is a centripetal acceleration, and the value of the centripetal acceleration is v square by r, where r is the radius of the circle. Now this, I have told, it is perpendicular to velocity. It changes the direction only and speed remains constant. Now if the motion becomes non-uniform circular motion, then speed is not constant. Speed changes, either increases or decreases. In that case, there is also another component of acceleration which is in the line of velocity. It may either increase or decrease the velocity. That is called tangential acceleration. And mathematically we write AT is equal to dv by dt, means rate of change of speed, or it is equal to dt of r omega, because v equal to r omega, we know omega is the angular speed. That means it becomes equal to r into d omega by dt, which is equal to r alpha. So AT, or the tangential acceleration, can be written as dv by dt or as r alpha. So in a non-uniform circular motion, then there are actually two accelerations, and the total acceleration is the resultant of AC and AT. Sometimes this total acceleration is acute. Acute means when the tangential acceleration is in the direction of velocity, then the resultant becomes acute angle with the velocity and the speed increases. But if otherwise, means tangential acceleration is opposite to the velocity, then the speed decreases and the angle between total acceleration and velocity becomes obtuse. So this is the concept about centripetal and tangential acceleration. Now there are some other important points which we have to mention here. See, this AT and AC, means tangential and centripetal acceleration, are perpendicular to each other. Now velocity is always changing direction in a circular motion, and centripetal acceleration has to be in perpendicular to it, and tangential acceleration has to be in its line. So they too also are changing direction always. That means all the three vectors, velocity, tangential acceleration and centripetal acceleration, neither of them are constant. They are always changing direction. Maybe their magnitude may be same, but their direction is changing always. In UCM, this means uniform circular motion, speed is constant, I told you. In that case, angular speed, that is omega, is also constant. That is an important point. And there are further important points that we know by Newton's law, that the acceleration is always produced by a force. That means if there are either AC or AT, they must be produced by some force, which are called centripetal and tangential forces. That means actually there will be one force which is resultant of these two forces, and there can be resolved like this, FC and FT. Now who can be that force? Which can be that force? Any real force or even pseudo force can act as centripetal or tangential force, any. But there must have to be a force, at least a centripetal force is a must for a circular motion, because without this there cannot be any circular motion. And if it is non-uniform, there will be an additional force, tangential force. That means these two forces are important for circular motion. Now these forces, any real force, means suppose tension, suppose gravitation, they can act as this. Suppose when you are revolving a stone about your finger with a sting, then the tension in the sting acts as centripetal force. And when earth revolves around the sun, the gravitational force acts as centripetal force. But one thing you have to be very clear about, that there are so many classification of forces like spring force, tension, like friction, etc., etc. But there is no such classification like centripetal or tangential force. It is not a classification of force. Any force which acts like this, behaves like this, becomes a centripetal force or tangential force. Means, let us take any person, he is not born with a profession, but somebody becomes lawyer, somebody becomes engineer, so later on they will be called engineer or lawyer. Means that is not their intrinsic property that they attain. So here also the forces are real or pseudo force depending on the origin, maybe tension, maybe friction, maybe gravitation. But if they act like this, if they act like this in a circular motion, they will be called either centripetal or tangential force. See, these things, these are very small points, but very important points and very confusing sometimes unless you are very clear about this concept. So I am doing this video because I know the students face lot of difficulties while dealing with circular motion, but it is not that difficult. Once you can understand the real concept, then there will be no problem. Then whatever exam you are facing, you can face with confidence. So this much today.